Hey guys, sure you can answer my screen at the time. Okay. My name is Precious, and today I'll be briefing you on this project and what it is about. So the title of this project is Igbo text named entity. Or how to edit this document. Entity recognition (NER) system using natural language processing. So we are going to move straight to the background of this study, like why this study in the first place. Chapter 1, named entity recognition. What is it? It is a task in NLP, that is natural language processing. Natural language processing, what we use in ChatGPT, them you get that involves automatically identifying and classifying named entities like person, location, organizations, and so on within unstructured text. My want as well as unstructured text. Unstructured texts are text that are not in a standard form, like maybe tables, CSV, comma, like they are not arranged. They are actually all over the place, and you cannot really sort through them. Like it's not something that you can put in table, put in column, put in row, something like that. A big example is the comments, your posts, your reshares, all those things that we do on social media. These are unstructured texts are being like compiled, and a lot of data, this is what we call big data, a lot of data are generated per second, every day per second. So these are unstructured texts. What NER is doing, NER is just a simple, it's a base task and a very crucial, like is the base, is one of the like roots of NLP, because you would like to, in all those unstructured, scattered text, it wants to, because maybe it wants to identify, for example, now in that social media stuff, somebody or they want to know what's the most talked about person, who is the most talked about person today in Nigeria. They will not come to Nigeria Twitter and use NER to now their model now. They will not identify the person or persons that are being talked about. So they identify and classify named entities automatically. We now find out, okay, these are the most talked about people. They will now use it and do their ads or recommend it to more people, so that there'll be more engagement. So we can see the use in social media applications. We can even see the use in healthcare. See the use in intelligent search. We see the use in information extraction. In all this plenty data, you want to extract maybe specific information that is useful for what you be doing, use NER. So although NER has been very developed and highly developed for English, German, Chinese, all these high-end or high resource languages, Igbo remains underrepresented. What's the problem of Igbo mostly? We have this very rich language, but we have faced some issues. For example, we have different dialects, right? We have different Igbo dialects. Eh? Then we have this Recom, Elu, Recom Allah, all this kind. So someone now, they are Obi or um Adobe. The O there might have bomb under. But another, this is an example. Another dialect now that Obi does not have any bomb or Recom or anything. So these are some of the issues that have been faced in why NER research has not really been advanced. I found this out by the literature review. So you have to make sure that you read the literature review and make sure that you understand all this. And this dialect of the problem also followed to make that there's no standardized and set corpora for Igbo language. What is a corpora? Corpora is like a data set or a data warehouse that contains thousands and millions of sentences, words, phrases of a language that you feed to a model, for example, and the model will now learn about that language, and you can use it for what you want to use it and do. But we don't have such large data corpora in Igbo. Okay, so these are some of the issues that we have in Igbo NER, Igbo Natural Named Entity Recognition. So what is the problem in the first place? And well, I've already stated the problem. I said lack of sufficient data set, corpora. There are few existing Igbo NLP. They are small in size. I've mentioned those. Okay. Aims and objectives, what we want to achieve. So make sure that you look all these aims and objectives that we wrote here. We are there actually at the end of this study. Your research questions is also in line with your aims and objectives. How can a high quality Igbo data set for NER be created? What are the best preprocessing techniques for preparing Igbo text for NER tags? How can an NER system be developed to accurately identify and classify unique entities in Igbo text? And how effective is NER? Is this NER system that we're going to create now? When tested using standard metrics using F-score, precision, accuracy, and recall. So read the rest of chapter 1 to get yourself acquainted with what we are going to be doing. I have mentioned in literature review chapter 2. You cannot know about the limitations, you cannot know about what you want to improve if you don't do a comprehensive literature review. So this is a comprehensive chapter 2 literature review. You go through them. Make sure you know 5 or 7 literatures at the back of your hands, right? So when you go through these literatures, you see how and what the problem has been for low resource languages like Igbo in the NER domain and why we want to solve it. So just read through it. It's GST, but it's very important. So go through them. All right. So we now come to where we started doing the work. So our methodology and our system design, we use an experimental methodology. Okay, what was our research design? We split our research design into 4 major phases. We started with dataset creation, script and collected data from these sources. Then, when we did finish doing that, we now manually put them in a .csv file and then put them manual annotation. Yeah, so okay, this you is your manual, this is your hand. So even like the creating of the data set was a big problem because for each of those words, you have to manually um say, okay, this one is a person, this one is a location, this one is an organization. Do you understand that kind of thing? So that was what was actually done. So the data set creation was actually hectic. So after data set creation, we now have the data processing where you do data organization, your label alignment. So I'm trying to go to the code. Okay. So this is in the code one. We are turning the computer where we are going to be the file and folder we are going to be working from. Here we loaded the CSV file. This was after we have already collected the data, put them in the CSV file like I mentioned, and we have done the manual annotation. These things are the manual annotation. Good. So pre-processing. See pre-processing. What did we start doing? We now converted it to a file. Now the model, they don't use the CSV to run their models. Here we're trying to understand our data sets. Then from here, we started making, we want to change, we now converted our .csv file to a .json file. And that .json file, there is .json file, is what the model can actually use for its work. Yes, so after the pre-processing, we move to the next stage. Let's read off. This was what we did in data processing. Then we went to model development. Now we use the BERT model. BERT is a transformer model. We use a BERT model from Hugging Face. We imported it from Kelvin BERT based multilingual case fine-tuned temperature. Oh, I wanna get the place that the code where we did the importation. So okay, see it here. This is where we loaded the model that we want to fine tune and improve. So this was it's okay. Then after that, we set up our training arguments. These are try and we did check some things. Oh, will this work? Will this work? Will this work? And then we said that okay, this is what we're going to use, and set our trainer that we're going to use for the training of the model. Then this is the training code, and then this year we now did the training. So we used the training epoch, 5 epochs. So read this training procedure. These are the things that we used. Some of them, but it's not right all because they're cumbersome. 5 epochs. This is the learning rate. The training batch size is 16. Okay, same batch size for both training and evaluation. All right. Then remember that we did not use GPU. We used the CPU. System was constrained. The model, the brand of the system, maybe the level of the system. Eh, but the only thing that happened was that the model training took longer time. Okay, that's what happened. So after everything, we did this model evaluation. Remember that we said that we are going to evaluate using our standard metrics. And these are the standard metrics that we used. So we see precision, recall, F1 and accuracy. They perform really well. 0.9% and above. That is 90 something percent and above. So you see that the model performed well. When we analyze some errors, checked some errors. These are some of the errors like I mentioned, the dialects. We see had issues with dialects because Igbo dialects are much. But so what is our existing system? Is this Masak NER model? It is a multilingual dataset developed for net edited recognition tasks. It's made up of 10 African languages: Igbo, Hausa, Yoruba, Amharic, Swahili, etc. 10 languages. Then these languages are used to train a multilingual birth model. So that's actually or more. Then they use it to fine tune. They use the data set. Remember that fine tuning. What is fine tuning? Fine tuning is taking your data set, further your specific task, and using it to train an already existing model instead of creating a model from scratch, which will take time, take resources, take energy. You use your data set and look for a model that might be able to that will do well. Then you use your data set and train that model to suit your task. So this is what they did here. This is what they did. So what's the architecture? So what they did, they created a multi-language data sets, Copera, did the processing, and they used it to fine-tune the model, the transformer model. Mhm. So the limitations and the challenges, like I said that the Igbo this thing was underrepresented. It's 10 languages, so it's not even specific. So the gas is too much. Oh, gas is too much. Reduce that gas. Uh, so what are we proposing in our new system? We want a specific, we want to just use our just Igbo data, our Copera. And then we are going to fine tune the model that we're fine tuning was is already it performs well in Igbo, but we are want it to perform better. So that's why we fine tuned it with all those parameters that we used. Yeah. this still face some issues, like this is the web interface. It still face some issues with it splitting names into subwords. So what is the new thing you are doing in our data? We still do data set creation Igbo. We process our data sets, did our model development and evaluation. Then we also added mods, a web interface. As many people might not be able to go into this code and do things, they now say let us create after fine-tuning our model and uploading it to Hugging Face transformers, let us connect it to a web application. That's when you search, paste Igbo text like Ada Obi na Emeka, all this kind of thing. Questions. It's able to tell you, okay, see, this, we are sure this is PIO. Remember that PERLOCORG, the named entities that we are considering, entity type we are considering. BIO is a tagging system that is used in NER. Here. So B stands for beginning of a sentence. I is inside the sentence. O is out, like at the end, outside. So our model is predicting that Ada will be Ada is a beginning person. Like a person starts a sentence, begins a sentence. But we see this issue of it splitting Adobe. Why is this splitting Adobe? Do you know Adobe is actually a sentence on its own, is word on its own. Alright, so that's an issue. Yeah, quite even with Emeka. So I have this theory that the first thing is before he breaks now, it still recognize that Emeka mostly begins is a person that begins a sentence because maybe by through his training, you have seen that Emeka will is a person that begins a sentence. Then he also has this confidence level. He's telling that it's 0.99% sure that begins a is a person name of a person that begins a sentence. Do you get? Okay. So all these are the benefits of our proposed system. So let's go through it. I've mentioned why it's important. We have more data set coverage, improved handling of the lesson extent. Relevance. We saw the relevance. That from this app now, so on, you guys can even come and say, okay, you want to use this and now start working towards creating a bot, creating a language assistant, all those kind of things. You can even do more research on it, make more bigger data sets, add more entity types. So here we have a sample of our data sets. Token, this is the words, the sentences, this is totally down. The copera as to how to add words, add sentences, and then manually add notes, say, okay, this thing usually starts here. Oh, my battery is low, so I have to hurry, guys. So our system design and implementation. Oh my god. These are the tools that were used. So good. This is explanatory. I've already explained how the data set is, so just read through the hardware requirements. This is the system that the model was trained on. Result and discussion, I've already showed it to us here. See how it works. You put your name or you put your sentence and output is the design of how it attributes. Okay. Performance and evaluation. We saw that our system performed well. If you say explain this graph, you say this loss, the training and validation loss curve. In the beginning, for validation loss, the loss was really, really low. Like it started low and it ended up to 0. After the first epoch, it was in maybe 0.1. Then to the final epoch, it was 0. While this one started at high, like 1 point in the first epoch, that is training loss. But as time went on, the loss was also reduced. So we can say our system performed well. See our analysis. So in summary, sum of everything that we have done, the conclusion of everything I have done, and the contribution to everything I have done from this instance. We will also summarize it in chapter 5. So this is it for Igbo text named entity recognition. Any question you have? always post it in the comment section or let me know. So this is an appendix. I added snippets of the app, code for the app, and then also snippets of the code for the training of the model. I also sent you guys, I sent you the GitHub repository. You see the full app model, the code for the app. So there's also a snippet of the dataset. So guys, this is it. And I hope we're able to understand. So thank you very much. How will I stop sharing?